Well, there's a law of sines and also a law of cosines, used for the same purpose to solve a triangle, often. However, sometimes you'll use the law of sines and you can't use the law of cosines, and vice versa. That'll depend on what information is given to you at the beginning of the problem. So what's given to you at the beginning of the problem will determine which formula you use. But in this case, I want you to just notice that even though it looks like there's three formulas here, the law of cosines is just one formula. So like if, for instance, I'm just going to draw a quick triangle here. So the law of cosines says, so if you look at the first example, it's a squared, so I'm just going to like square that. A squared equals b squared plus c squared minus 2bc cosine of a, right? So if you kind of follow with your hand how those parts of the formula jump around, a squared equals b squared plus c squared minus 2bc cosine of a. Just notice that if we look at the b squared one, the pattern's the same in terms of how you move. B squared equals a squared plus c squared minus 2ac cosine of b. So it's the pattern that's important, not the letters. So you could always just erase the letters that are given and rearrange them to your liking. The other thing to notice is that this suspiciously looks like Pythagorean theorem, and it kind of starts off that way. For instance, c squared equals a squared plus b squared is your Pythagorean theorem, but then you've got this extra term which really kind of compensates for triangles that are not right triangles. However, if it is a right triangle, that would mean angle C is 90 degrees, since the C would be your hypotenuse. And we all know that the cosine of 90 is 0, so this term would just drop out. So that's not critical for now, but it's just something interesting to note. Alright, so let's do an example. We're given that A equals 9, side B is 7, and angle C is 72 degrees. So I'm going to get my setup here. I'm going to call angle C 72 degrees. I'm going to call side A 9 and side B 7. And so you'll notice kind of, if you do a couple of these, that even if we wanted to use the law of sines, we couldn't, because the law of sines requires that you have all the information for at least one letter. So we would have to have had like all the information for A, or all the information for B, or all the information for C, because you need that in order to set up the proportion so that you only have one unknown. But that doesn't happen here, so we couldn't use the law of sines. So we can use the law of cosines. And to relate it to a picture, the information we're given is, let's say that's angle A, that's B, and that's C. We know that side A is 9. We know that side B is 7. And we know that angle C is 72 degrees. So notice that the information you're given in terms of how it's laid out in the triangle, you're given a side, you're given the next angle next to it, and then you're given the side next to that. So the SAS case is ripe for the law of cosines. We are not going to find all the missing information. We are just going to find side C in this example. So to find side C, I guess I'll use the version of this triangle. So there's side C there. I'll use the version of the formula rather that starts with C squared. So C squared equals A squared plus B squared minus 2AB cosine of C. We know all this information. We're solving for C squared, so I'm just going to plug in 9 for A, 7 for B, and 72 for angle C. Now what's nice is you can put this in your calculator right as it's written. So you can just put 9 squared plus 7 squared minus 2 times 9 times 7 times the cosine of 72. And when you do that, you get 91.064. But that's c squared, so we're going to square root it. And when you square root it, you get, oops, don't square root it that messily. When you square root it, you get c is equal to 9.53. And let's go out another one, 3. Alright, so we didn't solve the entire triangle, but that can be done. In this example, you at least saw how to get a missing side using the law of cosines.